Hello, I'm Jack. Welcome to Practical Programming channel. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, I explained how to build a simple 3D sphere with lighting effect. In this video, I will show you how to add the lighting effect to a 3D cylinder. Here, we will use the Git tool to clone the source code used in the last video. Here is the download link at GitHub repository. From this link, you can download all the source code used in the last video. Now open a command prompt window and run the following command: git clone, copy and paste this link. This will generate a WebGPU 19 folder on your local machine. This folder contains all the source code used in the last video. Now we want to change the name of WebGPU 19 folder to GPU 20. Rename Web 20 and cd into it 20. At this point, we are going to start Visual Studio Code with the command code period. This is Visual Studio Code interface. Okay, we can close this welcome page. Here contains all the source code used in the last video. Now open a new terminal window and run the following command: npm install. This will restore all the npm packages used in this project. Okay, finished. Now all the installed packages are stored in the node modules folder. As discussed previously, in order to add the lighting effect to a 3D object, we have to know the normal vectors at each vertex on the surface of that 3D object. Now let's add the normal vector data to the vertex data of our cylinder. From the src folder, open the vertex data.ts file. Now let's add a new function called cylinder data to this file. Here is the code for this function. See the cylinder data function. Here is the code. Here we consider a general hello cylinder. It is empty from the inside and has some difference between the inner and outer radius, as shown here. We can divide this cylinder into many slices to form the surface grid, like this. The unit cell is formed by the S and I plus 1 slice lines. Here we will use the cylindric coordinate system to get the position on the cylinder surface by calling the cylinder position a function from the mathfunc.ts file. Not here for the S slice. We have 4 vertices: P0, P1, P2, and P3. Their position can be calculated using these 4 formulas. You can see these 4 vertices has different radius and y coordinates. In order to create a vertex and a normal vector data, we need to perform surface triangulation. You can see here, each unit cell contains 8 vertices and 4 surfaces: top surface, bottom surface, inner surface, and outer surface. Each surface is formed by quadrilateral surface. You can see each surface can be divided by 2 triangles. You can see here, each surface has 2 triangles with 6 vertices. Here is the vertices definition for each face. To calculate the normal vector for this cylinder, we need to treat each face differently. For the top face here, The normal vector pointed up, so its normal vector is 0, 1, 0. You can see the top face 0, 1, 0, 0, 1, 0. For the bottom face, here they point to downward. Normal vector 0, minus 1, and 0. So bottom face all has the same normal vector, is 0, minus 1, and 0. While for the outer and inner faces, we use their vertex position for the x and z divided by the radius. For the outer, we divide by r out. For inner, we divide by r in. For the y coordinates, here we just set the y component to 0. This means the normal vector for the outer and inner faces are independent of the y coordinates. This cylinder data function returns vertex data and normal data. Now we can save this file and close it. Next, we will make some changes to the index.html file from this dist folder. Open this file. First, we need to change here the title, the 19th to 20, because this is 20th video series. Here, we also need to change the H1 title from sphere to the cylinder with the lighting. Here, we need to replace the sphere parameters to cylinder parameter. Here you can see we have R in, R out, height, and the slice division N. Now we can save this file. Next, we need to make some changes to the main.ts file. From this src folder, open the main.ts file. We need to replace the content with the new code for this file. Since most code for render pipeline and render path have been already included in the light.ts file, so our main.ts file here becomes very simple. Here we first introduce the create shape with light from the light.ts file. Then we introduce the light input interface from the shaders.ts file. Next, we introduce the cylinder data from the vertex data.ts file. Next, we need to create a new function called create a shape. This function takes the light input and the cylinder parameters as its input arguments. Inside this function, we call the cylinder data to get the vertex and the normal data. We then call the create shape with light function to create a cylinder with lighting effect. Here we define the default input parameters for the light and the cylinder, and we call the create shape function to create the cylinder with the default lighting effect. This part of the code allows the user to recreate the cylinder with different lighting effect by changing the input parameters. Now we finish the modification to the main.ts file, so we can now save this file. Up to now, we have finished all the programming. Now we can run the following command on the terminal window to bound the TypeScript code in production mode. npm run prod. Okay, the bound file is created successfully. Now we can click the Go Live link from the status bar area to open the Chrome Canary to view our cylinder. Click this link. Here is the red cylinder with lighting effect displayed on this page. We can make some changes to the input parameter and click Redraw button to recreate the cylinder. For example, if we set the diffuse and specular coefficient to 0, okay, 0, and 0, and make ambient intensity to 1, and click redraw body. You can see the cylinder looks flat and no 3D effect. Now let's add diffuse light and speckle light back. To change this to a small number, 2.2, and this 0.8, 0.4. And then we can also change the object color from red to green. This is 0, this is 1. We can also change the specular light color to yellow. Next, we can change the cylinder parameters. For example, we can change the inner radius to 0 to create a solid cylinder. Now, click redraw body. You can see we have a green solid cylinder with yellow specular light here. Now, we have completed this example. In next video, I will show you how to create a 3D cone with lighting effect. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.